Each morning, many of us begin with a quiet ritual, a moment of personal care in the bathroom. The razor, small and unassuming, is our tool of transformation, whisking away yesterday's stubble for a fresh start. We use it almost without thought, rarely considering its journey or the science behind its design. Yet this simple object is the result of remarkable engineering and natural history. From raw earth to high-tech labs, the razor's story is one of precision and innovation. As we explore its origins and evolution, let's look at this everyday object with new eyes. The razor is more than a tool. It's a quiet marvel of human progress. The razor's story begins not in a factory, but deep within the earth, billions of years ago. It's a tale of geological processes, immense pressure, and the slow dance of elements combining over vast stretches of time. Where iron ore, the lifeblood of steel, forms over eons. These iron-rich deposits, hidden beneath layers of rock and soil, are the raw materials that will eventually become the sharp edge of a razor. But iron alone is not enough. To become a razor, iron must join with carbon, a crucial element that will transform its properties. This union is the key to unlocking the potential for strength and durability, creating steel, an alloy of strength and resilience. It's a carefully controlled process, a delicate balance of elements that results in a material far superior to iron alone. Steel can withstand immense stress and maintain its shape, making it ideal for a razor blade. In massive blast furnaces, towering structures of fire and industry, iron ore is smelted at temperatures exceeding 1,600 degrees Celsius, a fiery crucible where the transformation begins. The heat is intense, the process mesmerizing as the raw ore melts and flows. Impurities are burned away, rising as slag, and carbon is carefully added to the molten iron, increasing its hardness and strength. This precise control over the chemical composition is what separates ordinary iron from high-quality steel. For razors, where precision and durability are paramount, only the purest steel will do. The slightest imperfection can compromise the blade's performance, so quality control is essential. Often stainless steel, a specific type of steel known for its resistance to corrosion, achieved with chromium added for rust resistance. This addition is critical for ensuring the longevity and performance of the razor blade, especially in the damp environment of a bathroom. This chromium reacts with oxygen to form an invisible, microscopically thin shield on the steel surface, keeping blades sharp and pristine, even in humid bathrooms where ordinary steel would quickly corrode. The molten steel, now carefully alloyed and purified, is cast into massive slabs, then hot rolled under immense pressure and heat into long, thin strips. This process refines the steel's grain structure, further enhancing its strength and flexibility. Imagine a giant rolling pin, but instead of dough, it's flattening white-hot steel. This is the birth of the razor's steel ribbon, the raw material that will soon be transformed into a precision-cutting instrument. From earth to engineered strip, a remarkable transformation driven by human ingenuity and the power of industry. The steel, now in its ribbon form, is ready for its next transformation, a journey that will take it from a simple strip of metal to a finely honed razor blade. The journey from raw ore, buried deep within the earth, to refined ribbon, ready for the next stage of manufacturing, is just the beginning of the razor's incredible story. The steel ribbon moves from brute force to finesse. Cold rolling compresses and strengthens the steel, aligning its structure for durability. But this process also makes it brittle, so the ribbon is gently annealed, heated and cooled to restore flexibility. Now perfected, the steel is stamped into blade blanks by high-speed presses, each blank identical and ready for the next step. At the stage, the blades are blunt, no edge, no danger. The transformation from raw slab to blade blank is swift and precise. The stage is set for the most critical process, grinding and honing the edge. The soul of the razor, its sharpness, awaits. Now the blade blanks are ready for their defining feature, the very essence of their purpose. These unassuming pieces of metal are about to undergo a transformation that will turn them into instruments of precision, the edge. The creation of this edge is a multi-stage process, a delicate dance between brute force and meticulous refinement. High-speed grinding wheels carve a precise V shape, aggressively shaping the metal to form the initial cutting profile. Sparks fly as the wheel works its magic, removing material with incredible speed and accuracy. This is where the blade begins to take its true form. But the edge at this stage is still rough at a microscopic level. Magnified, it would resemble a jagged mountain range, far from the smooth, clean cut required for a comfortable shave. Honing follows, a process designed to smooth out those imperfections and create a truly refined cutting surface. Honing employs a series of progressively finer abrasives, each one working to further polish and perfect the edge. These aren't your average sharpening stones, they are engineered with incredible precision to achieve the desired level of smoothness. This meticulous process works to smooth and refine the edge, removing microscopic burrs and imperfections that could cause irritation. The goal is to reduce the edge to just a few hundred atoms thick, creating a cutting surface that is both incredibly sharp and remarkably smooth. Automated systems with lasers are employed to meticulously measure the edge profile, ensuring it meets the stringent requirements. And high-resolution cameras capture detailed images of the blade's surface, searching for any flaws or inconsistencies. These advanced quality control measures ensure every blade meets exacting standards, guaranteeing a consistent and reliable shaving experience. Any imperfection, no matter how small, is instantly rejected, a testament to the commitment to quality. Consistency is crucial for both safety and performance. A single flawed blade can compromise the entire shaving experience. After honing, the blades are razor sharp, capable of effortlessly slicing through hair, but still too aggressive for skin. The raw edge, while incredibly sharp, would cause significant irritation if used directly. The next step will tame this edge, softening its bite and preparing it for the delicate task of shaving. This process is crucial for making it glide smoothly and comfortably across the skin, minimizing friction and reducing the risk of cuts or irritation. The blade's power is ready, honed to perfection, and possessing the sharpness needed for an effective shave. But it needs a final touch, a special treatment to ensure optimal performance and comfort. Enter the world of modern coatings, a realm of advanced materials and innovative techniques designed to transform the shaving experience. A raw steel edge is sharp, but it drags and irritates skin. To solve this, blades are coated in a vacuum chamber using sputtering atoms of hard materials like chromium or diamond-like carbon are deposited onto the edge. This invisible armor protects against wear and corrosion. Next, a layer of PTFE polymer, famously non-stick, is applied, making the blade glide effortlessly. These coatings are thinner than light's wavelength, yet transform the shaving experience. The result? A blade that's both sharp and smooth, lasting through many shaves. Modern coatings are the unsung heroes of comfort and performance. The blade is now ready to meet its partner, the cartridge. Science and engineering have turned steel into a shaving marvel. While blades are perfected, the cartridge, their plastic housing, is also engineered. Molten plastic is injection molded into precise forms, creating slots, pivots and guard bars. Microfins on the guard bar stretch skin and lift hairs for a closer cut. Above the blades, a lubricating strip releases soothing agents like vitamin E or aloe during the shave. Every detail from blade spacing to angle is designed for safety and performance. The cartridge isn't just a holder, it's an active partner, guiding and protecting the blades. Blade geometry is a closely guarded secret, ensuring a balance of closeness and comfort. The cartridge and blades are now ready to unite. Now blades and cartridges converge in a high-speed assembly line. Robotic arms insert each blade into its slot with microscopic precision, adding spacers and securing components. Lubricating strips and pivot mechanisms are attached, completing the razor head. Automated quality control checks every detail, alignment, presence and fit. Any flaw and the unit is removed instantly. The finished razor head is a marvel of integration. Steel, coatings, plastic and engineering in harmony. But before reaching your hand, it must pass one final test. The ultimate trial awaits. Quality control is relentless. In labs, high-speed cameras capture blades cutting hairs, revealing every detail of the shave. Instruments measure skin smoothness and blade drag, seeking the perfect balance of closeness and comfort. But real-world testing matters most. Volunteers shave and give feedback on comfort and irritation. Even after launch, razors are regularly tested to ensure consistency. This rigorous process builds trust. Every razor is scrutinized before reaching you. Only after passing these trials is the razor ready for packaging. Science and human experience combine to perfect the final product. The journey nears its end. The final step in this intricate dance of manufacturing is packaging. Here, automation takes center stage, ensuring each razor cartridge and its accompanying handle are carefully placed into their designated retail cases. It's a symphony of synchronized movements, a testament to the efficiency of modern production lines. Each package is prepared, ready to make its way to stores around the globe. From the raw, rugged landscape where iron ore is mined, to the brightly lit store shelf where the finished razor awaits a customer, the razor's journey is a remarkable blend of nature's raw power and human ingenuity's refined touch. It's a complex process, involving countless steps and a global network of resources and expertise. It's a story that begins deep within the earth, a story of geology, where the science of metallurgy transforms raw ore into durable steel, and the precision of chemistry creates the coatings that protect and enhance the blade's performance. It's a narrative woven with precision engineering, where every angle and curve is meticulously calculated and executed. All of these elements, seemingly disparate, are carefully condensed into a simple yet highly effective tool. We often overlook such everyday objects, taking their existence for granted without considering the intricate processes behind them. But their stories, when explored, reveal the quiet innovation that is constantly shaping our lives, improving our routines, and pushing the boundaries of what's possible. The razor, in its unassuming form, is proof that even the most ordinary things, the items we use without a second thought, can be truly extraordinary feats of engineering and manufacturing. So next time you shave, take a moment to remember the incredible science and meticulous craftsmanship that went into creating that small, sharp edge gliding across your skin. It's more than just a tool. It's a testament to human curiosity, our relentless pursuit of improvement, and the remarkable progress we've achieved through innovation. In the mundane, in the objects we use every day without a second thought, we often find marvels. If we simply take a moment to truly look, to appreciate the ingenuity and effort that went into their creation. The razor, a small, shining example of the everyday innovation that surrounds us, constantly improving our lives in subtle yet significant ways.